Hi, I'm Ben from Maxi. Today I'm going to take you through how to set up LightBurn to use the IndexX attachment with your galvo. We're going to be using LightBurn version 1.5.02. Currently in this version, the limit switches that are built into the table aren't able to be configured as a JCZ device within LightBurn. So for this video, we're going to do a direct connection of only the motor on the back of the IndexX to the rotary port on your laser. We're going to start with repeat marking or indexing of the table, and then we'll show you another way of operating it as an extended table for doing larger continuous pieces. Before we begin, you do need to have a working configuration of LightBurn to suit your galvo. It needs to be calibrated with material parameters set, and be confident that your laser is working as it should with stationary items before we add the extra complexity of the indexing table. This is important because we will use that configuration as a base for the setup of the IndexX. The other thing we need to have on your laser is a rotary port. Your laser must have a 4-pin rotary connector like this, because we're going to attach directly to it. We also need to make sure that your rotary attachment is working correctly first. It doesn't need to be fine-tuned. We just need to know that your wiring inside your laser is correct for your rotary attachment before we start trying to implement a new device. We will need to first check the stepper drive inside the laser. This is important. This limits the amount of current that the motor can draw. We want to make sure that that is not set too high or we risk damaging either the rotary, if you plug that back in, or the IndexX. We want to make sure that our current setting is set to the lowest of the two attachments. If we take a look at the stepper drive, on the front you'll see it has a table that looks a bit like this. It will have your current settings defined by these switches 1, 2, 3 across the top. You may have 4. We want to make sure that whatever setting we have to suit your drive is not more than 2.8 amps RMS. So in this case, we would set it to 2.69 amps. We wouldn't go to 3. That would be too high. So we'll use the settings on, off, off. Down the side of the drive here, we have our setting switches. We'll see switch 1 to switch 8. So we'll set our first 3 switches on, which is down, on, off, off. So the first 3 switches are on, off, off, which matches what we have here for this setting. Switch 4, we have switch 4 is off for half current and on for full current. We're going to switch that to off. We want that set to half current. What that will do is it will reduce the power to half when the motor is stopped or stationary. It just helps stop the motor from heating up when it's sitting there not moving. Then we're also going to set these last 4 switches. This is how many pulses per revolution. So this is how sort of accurate the motor will run. If we go too high, some of the speeds will be limited. If we go too low, we won't get the accuracy. So we recommend 12,800 pulses per revolution. We'll set that to on, off, off, on for switches 5 to 8. So once again, we'll look at the side. We've got switch 4 off, which is our half current, and then for 5, 6, 7 and 8 we have on, off, off, on being down. Your stepper drive may be slightly different. Just check your configuration and make sure that you can match it as best you can. The most important one is making sure that the current is not higher than 2.8 amps. 12,800 is also the best selection, and will affect the parameters we set in LightBurn. Once you've checked your stepper drive and you're happy that that is all configured correctly, we need to check the mounting of the table. We want to make sure that it's securely bolted down to your work base plate. Let's take our IndexX table and mount it at the base of the laser. Line up the 4 holes underneath with holes in your work table. Take the 4 washers and bolts that should have been included in your kit and install those into the base and bolt the whole thing down to the bed. Position the IndexX with the top plate in the middle of the base. This gives 4 access holes to the mounting screws. It also helps balance the table while you're setting up. Once you have it bolted down and balanced in the middle, we also want to make sure that your laser isn't going to tip or become unstable when it's extended out all the way to one side. Just check this, slide it by hand, make sure you're supporting it when you do, just to make sure the laser's not going to rock side to side with the weight of the table extended out one way. If your laser is a little bit rickety, or particularly with the compact versions or some of the split type systems with a smaller base, you may need to either secure that base down to your workbench or place a couple of bars attached or clamped to the frame just to stabilize it to balance the laser itself before you put the IndexX on top. We also want to check that there's adequate clearance on both sides of the machine. Make sure that we're not going to hit anything or damage anything when the table moves either direction. Take the motor cable. This is the 4-pin aviation socket. Both ends are the same. Doesn't matter which you choose. Plug this into the motor port on the back of the IndexX. We're not going to install the limit switch cable because these aren't currently supported by LightBurn, so we can leave that for now. Take the connector, plug it into your rotary socket and tighten it in place. Now that we have the motor cable connected, you can still slide this by hand. It may feel a little harder to move. That's okay, that's normal. That's power being generated by the motor and trying to feed back through the stepper drive. It may also feel a little bit stiff or crunchy. That's okay as well. Don't worry too much about that at this stage. As long as it moves smoothly and freely when you have the cable disconnected, then we're okay. On this machine, I'll just point out these buttons here because we are going to use these in the video. Our first one here is our power for the laser controller. That's just powering up the board with 5 volts. That keeps us connected for LightBurn. Our second one is our galvo switch, which is only controlling the laser head. And this one is the one we will use a bit during our testing. This is the main power supply for the laser source. That is the 24 volt or 48 volt power supply, which our stepper drive is also connected to. So turning this on will provide power to the motor inside the IndexX, which will then lock it in position. So you can see I can move it freely by hand now. Once we turn this power on, we hear the fans turn on and we can no longer slide this by hand. This is important because we don't have the ability to use the homing switches inside the table to reference to one side. So what we need to do at startup is be able to turn the power off, slide it all the way until we hit the hard stop, and then turn power on. And when we start up for the first time, we want to make sure that we've got the table positioned in the middle because we need to check that our movement directions are going the right way and we don't want to be crashing into the end stops. The last thing we're going to do is make sure that we've protected this before we start. This is the time where we might end up accidentally marking the surface. We don't want to damage your brand new product, so we're just going to put down a sheet of stainless steel or some other material on top. We're also going to wind the laser right up out of focus. When we do our testing initially, we'll also dial the power settings right down so we don't risk damaging the work surface of the IndexX. Once we've checked all the mounting and the connections have all been made, we'll go ahead and switch over to LightBurn. We'll go ahead and load that up. So here we have set up already. We have our configuration down here, our 20-watt fiber. This is just a basic setup. We're going to use this as our base. This has already been checked and calibrated, and we know that this is working. Yours might have a different name. We are connected to our laser here. As you can see, we're ready, and we've found our LMCV for device. So, first thing we're going to do is open up devices. We're going to select our 20-watt fiber. We're going to right click and press duplicate. We'll keep it the same, the JCZ fiber. We're going to give it a different name. We're going to call it IndexX. This will be our indexing configuration for repeat marking. We'll say finish. And we'll come back and make another configuration for extended table later. We'll just check up here and make sure that our rotary marking is not turned on. We want to make sure that there's no green light here. We can double check here and make sure enable rotary is turned off. Repeat marking doesn't use that function. It's separate. We'll go to our device settings. Here we are going to turn off the start marking port. We're going to set this to none. You can use that with your foot switch in this case because the limit switches haven't been wired up. We are suggesting you turn that off and disconnect the foot switch because when the limit switches and home switches are used, they often share the same input pins on the controller that the foot switch does. And what we don't want to happen is to have the table move, hit the home switch and re-trigger itself to mark, or hit a limit switch and start marking again. So we recommend disabling that here. We'll then come up to our laser tools and we'll select our repeat marking tool. Before we change anything here, we need to set up our device. We need to select motor 1. Most control boards only have one, the ones that are compatible with LightBurn anyway, the EasyCAD 2 boards. We'll select motor 1 and we're not doing a rotating table, we're doing a linear table. You'll see the difference change here is this steps per millimeter for linear or steps per rotation. This is really set up for rotation at the moment. This linear development is somewhat new, and there are a few things that LightBurn are still working on to improve this. In our steps per millimeter, we will enter 213.3. This is, let me just open up a calculator here so I can explain to you how we get this number. So 213.3 per millimeter, that's steps. We set our stepper drive to 12,800 steps per revolution. The motor inside the IndexX has a 20-tooth pulley using a 3mm pitch belt. So for every 1 motor revolution, it will do 60 millimeters. So we'll divide that by 60, and that gives us our steps per millimeter. As you can see, we'd like a few more decimal places to be highly accurate, but this is good enough for what we're doing for indexing batch marking. We'll set our minimum speed to 2000. You can set that slightly higher or lower. It can cause some buzzing if it's set too low, as it tries to move through sort of a dead band of acceleration. Maximum speed 30,000, an acceleration time of 500 milliseconds. You can play with these parameters a little bit if you need to make your motion a little bit smoother or faster. We don't recommend going much higher than 30,000 for maximum speed. It's not usually necessary, and going faster means you're more likely to miss steps as the motor moves, and you may lose some accuracy. We'll set this return to start position at the bottom here. This just means that once it's done the indexing, it will return back to the original position before it starts again. And our return speed is the speed of that movement as it moves back to the start. We've set that 12,800. It's not related to the steps. We could set that to 15,000. So we're sort of somewhere between the min and maximum speed. You could go back at maximum speed if you wanted to. That's all we need to set here. Currently, the home on start and homing functions aren't used. So we won't worry about those for now. And I will come back and explain the reverse direction selection here in a moment. So to get this ready to move, we need to turn on our laser power. This turns on the main laser source. It also energizes the motor in the base. Once that's turned on, this should be locked because the motor is now holding it. We can't slide it by hand. We want to start with the table in the middle position. If you've started it with the top plate all the way over to one side, we just want to slide this so we're starting around the middle, just so that we can check that we're not going to drive into any end stops when we run our first test. So we'll turn power on there. Okay, we're going to go ahead and run this test. When we do this, it's going to move one motor revolution one direction and then back again. So if you're thinking about a turntable, it would do one turn of the table and then come back on itself. In this case, it's going to move 60 millimeters, which is one motor revolution, 60 millimeters one way, and then return to the start position. We'll go ahead and test that. There we go, we can see that move. I'll just give you a better view. Okay, so if we're happy with that, we'll go ahead and press OK. And we're going to look at the jogging buttons next. Make sure that we're moving in the correct direction. We can set an increment, how far we want to jog the IndexX. We'll set it quite small to start. I'll make it 20 millimeters so we can see it in the background here. And we're going to press the right button. And we can see that it's moving to the right. If we go back, we start jogging it to the left, we can see we can jog it to the left. One thing to notice here is that our position right now is -50. If I just set 0, we can set wherever the table is currently, that's our 0 position. But what we notice is when we jog the table to the right, we should be going negative as we become closer to our 0, which we would expect on the left. However, our number is going up. Now, this isn't really a problem. We can change it to count the other way. However, if we change the counting and invert it, our jog buttons will end up being opposite. So we recommend leave it this way. It won't change the way that it functions. It will just mean that this number will go negative instead of positive. If yours is moving the opposite direction, you do need to adjust the wiring. You can't swap the direction just on the fly. That's not what this reverse direction option does. This reverse direction here only applies for when it's actually doing the index marking or the repeat marking. So in terms of direction, that's set by your wiring. When you hit that reverse direction checkbox here, it will change from when indexing positive to indexing negative. So we'll come back to that again once we start testing. If you need to swap the two, on the stepper drive, this might be a bit hard to see, you will have the motor wires coming from the bottom 4 ports. Usually they'll be labelled A+, A-, B+, and B-. Take the B+ and the B- wires and swap them around. Don't touch the A wires, leave those others as they are. Swap the B+ and B- wires over. That will just change the direction. What we want to see here is the jog moving the table the way that we expect it to go with the arrows. If that's all working, we can go ahead and run a small test. We don't have anything currently set up on our cut layer. We don't have any design here. That's okay for this test. We'll do a small increment. We'll just say we'll do 3 movements here. So if we had 3 parts laid out across the table, we would do the first one, move to the second one, move to the third one, and then return to the start. This here says 100 degrees increment. This is not degrees. As I was saying before, this is really set up for rotary options. We have set it to millimeters over here in our settings. However, this is saying degrees. It is millimeters, it's not degrees. So it's whatever we've got in our setup. So if we say 50 millimeters per increment, it is 50 millimeters. This will do 3 increments at 50 millimeters. So the first position it will mark wherever it is. It will then move 50 millimeters to the second position, move another 50 millimeters to the third position, and then return back to the start. We can set a pause after the move. If we're incrementing very quickly, we might just want to delay before it does the next movement. If that's all done, we'll just set 0 where it is. We'll press this button here. We want to just start with our table somewhere in the middle for this test. It's only going to move 150 millimeters. We just want to make sure that we're doing our movements in the correct direction. What we expect is that the table will start here and it will move across this way, bringing our second item. So if we have 3 queued up along here, we expect it to start on the left, move 1 position, do the second one. So we're going to be moving to the left. We'll hit start. See, we have no objects on the layer. That's okay. It still did the movement. We can press OK again and we'll see it moved again. And it will just switch over to the laser there and we'll just acknowledge that again. You can see we're actually moving in the wrong direction. We expected it to go the other way. So this is where we go back into our setup here. And this is the only thing that gets affected by reverse direction. We'll turn that to on, and this will change the direction that it moves. Our position here will still be positive or negative, exactly as it was before. The only difference is that our movement direction will be the opposite for the indexing. I'm just going to jog this back somewhere to the middle and we'll re-zero, set 0 again. And I'm going to run that test again. Press start. And now we're moving in the right direction. And you'll see here we're back at 0. If I run that test one more time, you'll see we're still moving negative even though we change the direction. So those numbers don't change. Okay, that's everything for the setup. Okay, I'm going to set up some artwork very quickly. We'll just import a logo here. I'll set that to my blue layer. We'll just do an outline. Make it a little smaller. Here I've set the power down to 1% and our speed up at 4,000. Don't really need to mark this. I'm happy just to look at a red light and just make sure that we're doing the indexing movements in between. That should be enough to demonstrate what we're doing here today. I won't do any physical marking on this right now because I don't have fume extraction in this office. It's more for the demonstration purposes. I'm just going to put something over the top of this to help protect it while we do this test. And before we actually do any marking, what we're going to do is move our table all the way over to one side. Now at the moment we've got our power on so we can't move it. We want to set our 0 position for this. Now we don't have the limit switches wired in, so we can't have this move automatically to the switch at the end. We have to do it manually. This is only something we need to do at startup. It should return back to the same position anyway. I'll show you how to do that. We'll first turn off our laser power. We can then move it freely by hand. We'll slide it all the way to the right. We'll hear the switches click. That's the home switch or the limit switch, which isn't wired in. But that's not a fixed reference for us. We want to make sure that we're repeatable. So we'll go right up until we hit the hard stop underneath. And you'll hear it when it does. It won't move any further. So that will be our 0 position. We'll go ahead and turn the laser power back on. And that is our home. Okay, we have our logo. Let's just run a quick red light on this. We'll go up to our laser tools again, open up repeat marking. Our setup is all set. We've got our direction correct. And what we'll do is we'll set this now to be 150 millimeters. We'll set our 0 because our previous position was 100, so we want to make sure that matches our end now. So 0 is 0. So we set our 0 position. This isn't an ideal position for 0 because it's actually running over the top of our limit switch. Every time we do our movements, it's going to come back and it's going to be over the limit switch and it's going to be right up against our hard stop. We still want to have a position that we can come back to repeatably if we need to reset something. So what we can do is we can just jog the table to the left by 5 millimeters, 10 millimeters. And you'll see we're now at -5. This means we're now 5 millimeters off our hard stop. We can then set that as our 0 position. That can become part of our home procedure. We drag the table to one side, we turn the power back on, we manually move it 5 millimeters offset, we then 0 it, and that is our home position. This is the best way to operate the IndexX from startup. We're going to run this now. We should see a red light of our Maxi logo repeated every 150 millimeters. I'll go ahead and start this now. Well, that seemed to work quite well. We'll go back and we can change this to whatever count we want. We could do 5 of these across the table if we wanted, with 100 millimeter increment. Very quick and easy to adjust this. We'll run that now. So that's basically it for repeat marking or indexing. There's not really anything left to configure. You can go ahead and look at the variable options for making nameplates or batch marking different logos, whatever it is your application is. It's just a matter of adjusting your count and your increment, and you may want to adjust your pause after move if you need to. Next, I will show you how to set up for an extended workspace. Okay, now we're going to look at the extended table function. This is for marking long, large pieces. This isn't something that's natively supported by LightBurn at the moment, and this is something that they're working on developing. What we're going to do is we're going to use the rotary marking, not repeat marking, the rotary marking, similar to what's used for engraving around the outside of a bottle, to make the IndexX table move to do a long piece as if it was a giant bottle that size. So we'll just switch back over now to our display here. We're going to create a new file. We're going to go to devices again. We can keep our IndexX. We could use this one again, but what I'll do is I'll just create a new configuration for this one. This is helpful because we do need to turn on rotary or not rotary, depending on whether we're doing repeat marking or not. So it's better to just have a separate configuration where it's already turned on and set up, ready to go. So once again, we'll right click, duplicate. We'll give it a new name. We'll call it IndexX extension. We'll select that one, say OK. We'll turn on the rotary setup here. We're going to work with a chuck. So the way LightBurn is meant to work for rotary, it's designed to do one revolution of a bottle. So we would start at one side of the bottle, we would turn it up to 360 degrees or a certain distance around the bottle and then turn back. So our normal settings here, we would have our rotary settings set to however many steps per rotation we have on our stepper drive. So 12,800 is what we set earlier. And then we'd put in either the diameter or the circumference of our bottle here, and it will calculate the other one for us. Then what we do is we set a split size, which is, I guess, the width that we're going to mark before it does a movement. So it might do 10 millimeter increments and shift. Typically on a bottle, it's more around 2 to 3 millimeters. So what we need to do is we sort of have to trick this a little bit. One motor revolution on the IndexX is only 60 millimeters. So what we have to do is we have to calculate out how many steps per rotation for an entire length of movement of the table. So the way we do that we take our distance that we want to move, which is our total table length, which is 700 millimeters of movement. That's how much travel we've got. The actual plate is 1 meter long, but we've got 700 millimeters of movement. We're going to divide that by how many millimeters per motor revolution, which we said was 60 millimeters we move. So to do one table movement, full length table movement, we have 11.66 recurring motor revolutions. We're going to multiply that by the number of steps per revolution, which was our 12,800. And this is how many steps for one table length. So what we're doing here is what we're effectively doing is pretending that instead of this distance around the bottle, we're basically taking a giant bottle circumference, stretching it out flat to be one full table length. So we're going to take this number, our 14933.33, and we're going to enter that here in our steps per revolution. And then for our circumference, we'll put that to 700 millimeters, which is our table length. The split size we can come back to and adjust those later. Before we start this, we need to enable our rotary. Now, in our previous configuration for repeat marking, if we had reverse rotary direction turned on, which we did, and this is the way we recommend to do it, you need to turn that on here as well. Otherwise, the table will try and move in the wrong direction. We should have the motor speed settings set to 3,000, 2,500, 500 and 10,000. These are a little bit different to what I had previously in the repeat marking. These are equally as good. You can set this to 2,000 if you prefer. Anywhere between 2,000 and 3,000 is good for a minimum speed. Anywhere between sort of 22 to 30,000 is good for a max speed. 500 milliseconds is perfectly fine. You can slow that down or speed it up slightly. Anywhere between 300 milliseconds and 1,000. And our return speed, we've got at 10,000 here. What we'll do, just for a quick test, so do we make sure that we're actually going the right direction and everything's looking correct. What we'll do is we'll just set this back to 1 motor revolution. We can always come back and update this again. And we'll move our table, move the IndexX to the center, turn the laser power on again, and we can run a test here. So we're using the x-axis, and we'll just run test. And once again, it just does the 1 motor revolution because that's what we've got set here. If we'd left our settings as they were before, it would do a full table movement. So we can see our first movement, we want it to be moving to the left. So we'll go back and change that now, and then we can run a test that's closer to the full length. Turn that off. We'll move it right down to one end. Until we hit the hard stop. We'll put our parameters back in here. We'll set our circumference to 700 again. We'll turn our laser power back on to energize the table. And then we'll run our test. Now what should happen this time, it should move a full 700 millimeters and then move back again. As if it's turning a bottle 1 revolution and back, we're turning our giant bottle or our full table length 1 direction and back again. And you would have heard that do a very small click when it hit the hard stop at the end as well. We can offset that again when we actually run the marking. We need to understand how the workspace is set up for this artwork and the way that rotary marking works with the table. I'm just going to write out the alphabet here. So we've got something nice and long. Now, the way that split marking works, normally you would do a small split and then move. And what's happening is the bottle is being positioned directly beneath the laser at that point. So our table, our IndexX, is going to do the same thing. So we've set our 0 position to be hard up against the end. Now if we look at our text here, if I switch over to our display, we've got our alphabet laid out. If we look at the letter A, the laser is going to try and position itself directly over the A to mark. Now, if our 0 is the end of the table, this is going to be past the edge of where the laser can reach. The table can't physically move to get this A below the center line of our laser. If I drag a guideline out here, so this is the center of our laser in our work area, our standard work area. We can't move the IndexX to get this 0 here, because this point in our workspace is sort of beyond our hard stop. When we were doing repeat marking, that was fine because we're marking in one fixed position and the galvo is doing all the movement over that area, and then it's moving the workspace along. For rotary marking or extended table, it's trying to move that workspace, the whole workspace, under the laser head to get the part that's being marked in the right spot. So this makes a bit of a limitation for us. We cannot have any marking to the left-hand side of the center of our workspace. We need to be past this line. So this defined work area space is configured in our device parameters for the lens. We can't change this at the moment in LightBurn. So what we need to do is define some boundary of where our artwork can be positioned. So the way I like to do that, I like to use these new guidelines that have been recently introduced in this version. I like to drag a guideline to the top of our workspace. We can do this by just going to the top here until we see our little guideline symbol. So what I'm doing is effectively drawing our own boundary for our artwork. So my lens is a 210 by 210, so I've dragged this guideline here to 105. So I don't want to have any marking or artwork in this area over here. Our maximum travel is what we're limited by. Even though our table is 1 meter long on top, our maximum usable area at the moment with LightBurn and with EasyCAD 2 is 700 millimeters of travel. So we'll take our 105 millimeters that we had here and we'll add that 700 and we'll drag our guideline until we get to 805, and this defines the edge of our work area. So I'll just drag this one here as well, just so we can see. I'll drag this one here to 1 meter, roughly. We do have a little bit more movement in here, but I've set it at 700 just to be nice and simple. So what we have is this outer boundary here. That's our physical tabletop, but our usable area is in this inside area. I'll just remove these two guides because they are a little bit confusing. So this is where we can position our artwork. We could have a few different objects in here. We could put circles. I'll just draw a few bits and pieces for the demonstration. Once again, I have some line settings over here. We're just going to outline these items while we mark, just to preview where it's going. I've got the speed set high and the power set very low. The laser's also set up and out of focus again. So what we'll do, now that we have this set up, we'll make sure that we've moved the table to the end once again, turning off power, making sure we're up against the hard stop. Turn our power back on again. We'll then check that we have our rotary enabled. We should see our little green dot up the top here. I'm sorry you haven't been able to see the settings that I've had. Up here we have our line and speed and power. I've set these very high at 4,000 and our power to 1. Just so we're not marking anything. We'll just use this as a red light preview to actually see how the whole marking works before we get started. We'll go ahead and press start. We can adjust the split size here. This was available in our setup as well, but we'll just do it directly in our rotary marking here. What we'll do is we'll just set our split size at 30 millimeters, which is fine. We can break this up. You will need to experiment a little bit with this depending on what you're trying to do. I usually try to make the split size match full shapes of items if possible. If you're looking to overlap items, so build a large image, it's best to keep this split size very small. For instance, 2 millimeters, it will be quite slow, but any variation in your calibration will be overlapped. If you try to mark a big area and move, trying to get a perfect lineup between two pieces of artwork after doing a big marking relies very heavily on the calibration of your lens, where the two pieces match up. So by doing a very small split size, these aren't as obvious. You can adjust the overlap. This can be very helpful if you do have a little bit of variation in your calibration or the movement. This will need some experimentation. We haven't done a lot of development and testing with this at the current time, but it's a similar process to what people are doing on bottles when they mark around the outside. They just adjust for the overlap to get it perfect. We don't want to change our object diameter. This is calculated for us when we entered the 700 millimeter circumference in our settings. We'll run whole shapes if possible. This just helps eliminate overlaps in our marking, so it will do each letter separately if it can. It will break up the position of each letter and try and move in between them. We can set a maximum shape size here. What this will do is it will mark individual shapes, if it can, that are below 20 millimeters on its own. So it will position the laser over that whole shape and do it all as one go. If the shape is bigger than that, it will get split up if it needs to. We'll run all shapes in each slice. We'll just start that again now, and when we press play, we should see it move the table to each of the letters and automatically mark everything that's been laid out, including this rectangle all the way over to one side. I'll press start. It's a bit hard to see exactly what the letters are from this camera angle, but it is marking each letter of the alphabet. And our rectangle at the end. Okay, once again, we heard a little click and a clunk when it hit the hard stop at the end there. That's because that's our 0 position. So when it hit the end here, this is where we had a small offset when we were doing our repeat marking. We really should be doing the same thing again. See, our position right now says 700. What we'll do is we'll just jog our table to the left 5mm and we'll set 0. And then we will start. And it should do the same process. It shouldn't have said 700, it should have been at 0. This time when it returns, we shouldn't hear the click of it hitting the hard stop. And we're back to the start. Now we can speed up the return movement if we want to, if we're trying to speed up our production. So we can always go back and adjust those motor parameters. For example, our return speed, we might want to do that at full speed. So we'll set that to 25,000. It's usually good to have it a little bit slower just so we can see and know that it's a different sound in the background as well. So you know that it's finished. So that's about all there is in the setup for repeat marking. We've saved it as a separate configuration. If we want to switch between them, this is where I was showing you before. If we just switch back to IndexX, our rotary's been turned off and our settings are already set for repeat marking. If we go back to our extension table, our rotary option is turned on and all our parameters are set. So when do you want to use each type? For batching similar items or repeat marking, for bigger work pieces and larger laid out artwork, use the extended axis. That's about it. I'm sure there's lots of things we have missed or not covered. If you do have questions, please make sure you reach out to us, message us through our Facebook page or through our contact form on our website. We're here to support you. We'll do the best we can. Thanks for watching. We appreciate your feedback. We look forward to hearing how this has made your shop so much more profitable and expanded the capabilities of your galvo laser. Thanks for watching. See you next time.